Okay. Hi, I'm Noah. This is week 13, assignment 13, where we'll be talking about logistic regression. Actually thought I could get a little bit further with this assignment, and I kind of did, at least with the first question, not so much as the second one, but I'm still going to try and explain again my interpretation. So without further ado, let me just share my screen. I gotta find the right one because I have like 15 to 20 different tabs. Starter error weekly. Okay. All right. So I can't even see my own screen. That's awesome. Oh, wait, this is my screen. All right. So just going over very briefly, the first question for the logistic regression assignment, is to use ELS 2002 .jasp and then conduct a logistic regression of grad school regressed on writing plus SESQ. Let me remind myself real quick because I actually forgot what that meant. Uh, SESQ. Okay, I don't remember what it is, and I forgot what Dr. Cole and Dr. Wassilov had called it. So I am just going to refer to it as SESQ. And hopefully, I feel like I missed it. It's definitely not success or failure. I know that for sure. Um, okay, I don't remember what it's called, so I know in the video he went over it.
We've got sex, race, grad school, prep, writing, SES, and SESQ. So let's edit the data and see what we really have. And so just double click on sex. So you see we have male and female. Race, we have Asian, Black, Hispanic, white. The reason why I coded these both as Hispanic because before in the original data set was, I think, well, there were two different ways that people could identify themselves as being Hispanic. Grad school, I've got one is yes and no is zero. And the way logistic regression works is the first class, whether it be number one, looking at in what class preparation scale. So it's continuous education opportunities.
Socioeconomic status. That is what that means. Awesome. I'm still going to refer to it as SES because that's a lot easier to remember, but I'm going to make a note of socioeconomic class. Perfect. Okay. So as you can see, I put in the file into JASP. I had to actually have Dr. Wassiloff send me a spreadsheet first of the data, and then I could open up JASP, or I can open up the spreadsheet into JASP because again, my computer is very, very special. But anyway, I did a matter of changes to the labels. So like for sex, for example, I had to change it to female and male, but I still kept the numbers just to help me differentiate between the two a little bit. Same thing with, oh, race, I did it for one of the questions, but I guess I didn't do it for this one. So when I get to that question, then you'll be able to see the differences. It doesn't go into this one or this question either, so that's good. Grad school, I left the same. Prep, writing, SES, SESQ, I actually had to do a different formula, or I had to do the same formula that he had given us in class, but I wasn't able to utilize this data correctly. So I ended up having to do another R Studio code. And I did the same thing for writing because that goes into the question, or at least question number one. Conduct a logistic regression of grad school regressed on writing plus SESQ. And if I look through our example real quick, key results, prep, lab ratios, lab prep, teasers. Okay, that's why. Sample probability of attending grad school by race, categorical predictor. I'm just reading the examples right now. I oh, okay. I really hope I did this right then. Moving on, the way that I started this first, I first changed the SESQ and looked into descriptive statistics. Specifically, I did this for it was easy to do it for SESQ since he had already done it for us. But for writing, I had to make my own um RStudio, and I wish I could show it on here, but apparently it doesn't let me. Um, so yeah, I did that for writing, and then the way that I was able to put in the labels for specifically R itself, um, if it's less than this percentage, so like let's say for example, if it's less than 0.7, I put it as number one. If it was less than or above 0.05, I put that as a two, and then anything beyond that, a 0.8, I put as a three and four. But that's how I was able to write the RStudio code for writing specifically. And then moving on afterwards, I clicked on regression, logistic regression. You can see I have the variables right here. I inputted grad school as the dependent variable since that's what it was asking us. And then from there, I put in the factors as SESQF and writing F since that was my way to differentiate my own personal RStudio codes. And then afterwards, regression coefficients, I clicked on estimates, odds ratios, confidence intervals, I left it at 95% and then odd ratio scale. And then for the plots, I think, yeah, I clicked on display conditional estimates plots, and that was pretty much the similarity between myself and the video. But going over the specific data, right now I have it as, how did I have this as before? Okay. Um, yeah, right now, well, I just changed it, but now it's at male one as the what do you call it? The reference group. Yeah, the reference group. Male one is the regression or re reference group, and then if I do that, then it will change it to female. But for right now, for male, the reference group is still the odds ratio for the intercept is 0.645, which represents the baseline odds for the attending of graduate school with males as the reference group. For females, it would be the same number, 0.645. And then going down into the example, looking at teasers R squared. Um, right now with females as a reference group, well, as a whole in general, right now it's 0.175. And based off of the explanation in the lecture, it means the model explains only is Wait, that doesn't make any sense. 0.007 explains only 0.7% of the variance in the probability of attending high school. So this is a high indicator, a very, very high indicator, if I'm not mistaken. In the example, it's saying that 0.007 means the model explains only 0.7% of the variance in probability of attending graduate school. Here, it's 0.175. So that's to me, that seems like it's a very significant predictor, a very strong one. Um, so it doesn't necessarily need any more variables to um, to explain the correlation between SESQ and writing with attending grad school. And now looking at our estimate plots, um, you can see here, this is grad school, this is the socioeconomic class. 4 is ranked higher. So those in group 4 were ranked higher, um, higher percentage in going to grad school, while those in group 1 were seen as having a lower attendance or pursuit of going to grad school. Same thing with writing. I'm actually not 100% sure what writing is supposed to necessarily explain. Let me pull up that video real quick.
Then writing is a writing ability.
Writing ability scale standardized to mean equals 0 and SD equals 1. I have no idea. Uh, Writing ability scale standardized to mean equals 0 and SD equals 1. So less than 0 would be the mean, and SD, standard deviation, equals 1. Yeah.
SES is socioeconomic status, concerned with the actual scores of prep, because we've standardized them. And that by doing that, we can compare a lot of variables that have been standardized, which is what's convenient about standardizing variables. And then writing is a writing ability scale, and SES is so.
Oh, okay. So that doesn't have anything to do with it. Never mind. It just means writing ability to scale. But in group 4, again, you can see that it's seen higher. Um, the writing ability in group 4 is seen as higher. So that would indicate that those in group 4 are more likely to attend grad school, while those like ranked in the 3, 2, and 1 were seen as a downward trend of lower. And if I switch this real quick, I wonder, um, you don't really see that much of a difference now that I'm looking at it. So to me, there doesn't seem all that much of a relationship between gender and SESQ or writing. Let me double check one more time because I'm curious. No, it doesn't look like it. Let me see. No, it doesn't look like it. I think what it actually is doing though is if I'm paying attention correctly. No, it's actually not doing anything. Okay, my bad. I thought for a second that it was changing like the size scalings of the dots to indicate like the average deviation, or the average range between groups 1, 2, 3, and 4. Like you can see like the lowest percentage in group 3 is like about 65%, while the highest is seen at like about 75% in group 3. That's just an example, though. The margins seem to be a lot bigger in group 3 compared to groups 2, 1, and 4, where they're seen like the line is seen pretty close. And it's the same thing for writing 2. 1, 2, and 4, their margins seem to be a lot closer to each other in the average, while as 3 seems a bit more spread out. Um, is there anything else I needed to add? What if the OR is significant and below 1? Yes. Interpreting odds ratio. Nine three seven. I really wish my graph would show what this was showing. Um, because I don't, hang on, I can actually, let me share the example that I'm looking at. So right here, I really hope this is showing it. So right here, it is showing the example that I've been using to like reference because sometimes I have to use this a lot to explain what I'm trying to talk about, since I'm very limited with like the amount of stuff that I can share. But anyway, there's another step when he was explaining the video, and it has to do with the model, or not the model type, but the statistics. For some reason, mine is seen differently compared to his, and his specifically shows the in the coefficients section at least, it shows a model, the M0 and the M1. Um, and it just adds the variable to this model itself to show like the significant impact, which would be for this example would be 0.937. That would be the how's he explain it? For every 1 unit increase in alcohol concentration, the odds of the wine being white decreases by 60 or 6.3%. 1 minus 0.937 equals 0.0631. Other words, wines with higher alcohol concentrations are less likely to be white. Um, Again, it shows it right here too. I wonder if I just missed something. Standardized coefficients. Mm, no, I did not. Okay, that's interesting. If only. Okay. I think I explained everything that I could in this one. At least I hope I did. Um, I'm more of a visual person where it's like I can like interpret a graph. I just don't feel confident that I'm interpreting it right, unfortunately. Um, but yeah, enough showing of that one. Moving on to question two. And this one is well, would be a little bit similar. Conduct a logistic regression of grad school regressed on SES plus race plus SES times race. That's a lot of addition, in my opinion. But let me try and explain this real quick. So this is ignoring that. Again, I just added the spreadsheet onto JASP. And for this one, you can see that I had to change the, let me change this real quick. I know this is female. Female 2. And then this one is male 1. So you can see I did that. I had to input this manually on my own, but you can see I changed this and then I had to change this race. They're not organized. I was kind of afraid to touch that, so I just ended up leaving them alone. Or no, no, no. Oh, okay, yeah, that's right. I forgot. When I was doing this, I was changing the order of things. Um, but yeah, no, Asian 2, Black 3, Hispanic 4, lowercase Hispanic with 5, and then white 7. Um, Similarly, originally I was gonna try and make a race um into a nominal column type. And then I realized that wasn't going to work out and that these numbers in here were ordinal. So I gave up that idea and tried my best again with this because again, there was a lot of things that it said that I needed to put in and I wasn't able to. Um, anyway, moving on. Uh, that was the other thing. So I couldn't really add, yeah, I couldn't add race either into covariates because that's only a, what's the word called? Scale. It's a scale column type. So I just ended up putting it with the factors because that was another factor that I needed to add. Grad school is still the dependent variable because that's what you're talking about. Um, right, I didn't actually have to use descriptive statistics, but in the beginning when I was trying this out, I still put it in. And then I probably could put, no, yeah, I could put race as a split. Yeah, so you can see with this specifically, let me move. I think I can move this. Perfect. That makes things a lot easier. Um, just gonna play around with this a little bit. Yeah, better put. Oh, wait, I probably shouldn't play around with this too much. Yeah, I forgot. Last time I tried doing that, I almost crashed my computer. So let's try and not do that again because I was not happy. Um, not sure why these column types aren't really showing as much compared to these three. So something tells me that there's some data issues specifically that I wasn't able to clean up. I'm gonna get rid of that for right now. Valid, valid. Missing 216, 280, 169, 196, 1 or 972. Not really sure how accurate some of this stuff is. But the mean for Asian 2, 0.8, 0.6, 0.7, 0.9, 0.6, 0.6, and then zero point 0.8 standard deviation. So that would be 1 minus, no, that would not be 1 minus. Is it? Wait, hang on. I can't math in my head. 1 minus 0.866. Okay, that is not. So maybe it's, you know what? Forget it. It wasn't needed in the example, or at least I don't think it was. So I was trying to do something and it didn't go the way I wanted to. But moving on. The dependent variable again is grad school with covariates SES, uh, race, and SESQF. I left as the factors. I can't do, I can't add another model type, or how was it that he described it? It's another, I think it's a model factor actually, now that I'm thinking about it. Give me a sec, let me speed run this. Just, it doesn't add. He's a troll for doing this.
It's different model were not necessarily too significant for females to be okay. Because prep on the odds of attending graduate school is slightly stronger than standardization equally up. The writing scores can do for your assignment. You're going to do grad school, regressed on F, and there's no interaction term. It's just let's look at the writing score. So now we have the independent variable, which is a scale, just like prep. It's got a mean of 0, standardization units of 1, and it's self-reported writings. I think it's actually test scores. How well did you write? And then we have socioeconomic status, which has been turned into a categorical variables at quartiles. And then for your second question, I want you to now do the continuous variable SES and the categorical variable race, but then do an SES times race interaction. It's going to be really interesting. Okay, so not much of prep. One variable. Let's add in sex. Significant. This one variable. Let's add in sex and just
I can't find it anymore. Okay. Um, yeah, I can't find it. We're just gonna move on. Uh, but there is like another section where you're supposed to put each individually as a model term, I guess. Um, but I can't do that. So moving on, I kept on adding the regression coefficients, estimates, odd ratios, confidence intervals, and then the odd ratio scale. And then still left it as display conditional estimates. So looking at this thing, not this thing. Well, yeah, it is a thing. But 1 point or no, how is this? 1, 2.9% of this graph, or not this graph, but the it represents how well the model predicts the outcome. Meaning that 12.9% of the variance in the probability of attending graduate school is represented through this. The odds ratio for this is 7.503. Um, Sex isn't a part of this, so I don't know why I'm doing that. I'm just gonna leave that alone because that's my code. But looking at the chart, you can see socioeconomic status or class, sorry, socioeconomic status, um, those in the two range. So, um, the estimate, sure, standard error, sorry, the Z pattern. I don't know what that is. I don't know why I'm talking about that. Um, Pretty sure you're looking at the estimate for this, but the estimate for SES right here shows that those with a standard deviation of 2 have a higher chance of going into grad school, while those with a standard deviation of -3 have a lower chance of going into grad school. And these groups are based off of the socioeconomic status. Not the same thing with race, but this one again um, shows the groups individually and their percentages of going into grad school. So Asians are the highest. Their average is pretty close to both the margins. Black has a 0.75% chance, Hispanic 4. They also have about 0.75. Their margins are a lot bigger compared to Black. Lowercase Hispanic 5. Um, a little bit similar. Their margins are also similar to Hispanic 4, but I think it's a little bit lower. So just under 0.75, or if it's at 0.75, then Hispanic 4 is a bit higher. And finally, white uh higher. I'd say it's about close to even to Hispanic 4, with the margins just being a little bit shorter. And then finally for SESQF, this one's just a more of it's kind of is it explaining the same thing? I think it's explaining something a little bit more different. But as you can see here, the socioeconomic class F shows that each group shows a high percentage of going into grad school regardless. Um, so yeah, I think that checks out everything, or at least everything that I could have really explained. I really wish I could follow along in class, but because my computer likes to give me issues, like this week, for example, I wasn't able to. But again, that was to the best of my ability. And then yeah, that's it.